I'll just go ahead and start. First of all, thank you for everybody visiting with us today for the hour. We have Dr. Dave Reidmiller with us. He's the new director of, I believe, the newly formed Climate Center at the Gulf of Maine Research Institute. And just to back up a little bit, we've had a long-term association with the Gulf of Maine Research Institute, primarily through Andy Pershing, the former chief scientist, who continues with our institute. And we look forward to strengthening this relationship even more so. Obviously, GMRI does things that are extremely complementary to what we do. So we look forward to it. So welcome, Dave, to Maine. Dave has served in a variety of senior positions for the federal government. He was the acting director of the Northeast and Southeast Climate Adaptation Science Centers as part of the U.S. Geological Survey. He has overseen unique partnerships between federal government and university, largely related to fish, wildlife, habitat, and people adapting to a changing climate. Before that, he directed the fourth National Climate Assessment as part of the White House Office of Science and Technology Policy, where he coordinated the work of 300 plus volunteers across the country to address climate risks facing the nation. He's got a deep understanding of international climate science policy, tremendous amount of experience. He served in the State Department's Office of Global Change for 5 years under the Obama administration. He led the U.S. engagement in the IPCC events and was the lead U.S. science and technology negotiator for the Paris Agreement. Many overlaps with things that we're interested in here. He's also served as a fellow in the U.S. Senate and advised Senator Mark Udall on a range of energy, environment, and public lands issues. So it's a great pleasure to have Dave here. It's a great pleasure to look for even more involvement between CCI and GMRI. And we look forward to your presentation today, Dave.
Great. Thanks a lot, Paul. Appreciate that introduction. And thanks to Becky and everyone at CCI for giving me the chance to talk to you today. So I'm basically going to kind of provide a bit of an overview of climate risks and response options in the Gulf of Maine. And this is largely going to pull from kind of my experience, leading large scale assessments, whether it was kind of our involvement in the IPCC or the NCA, Maine, obviously, in part through the leadership of Ivan Fernandez and others, have done some really great scientific and technical assessments of climate change across the state of Maine. You'll see some of that content drawn into this report or into this presentation before I kind of pivot towards what we're likely to do in the context of the Climate Center at the Gulf of Maine. So with that, let's start with a little bit of climate change in the global ocean and what this really means. This is no surprise to anybody, but a figure from the National Climate Assessment Oceans Chapter, which was led by Andy Pershing. And it's really just emphasizing that, unsurprising to all of you, of course, that humanity across the world, but in particular in the US, relies on the ocean and marine environment for a variety of benefits, whether it is economic, recreation, or just cultural identity. And a number of these things, obviously, a number of these benefits are at risk as a result of climate change. And it's important to know that climate change has a cascading effect on things that we care about. So this is a complicated figure from the IPCC special report on oceans in the cryosphere that came out a couple of years ago, but it really just shows that despite the otherwise, somewhat straightforward relationship between warming and impacts on the physical system, perhaps there are not only a cascading consequences on other systems, whether they be biological or societal, but that those cascading impacts can have sort of knock-on effects back to those physical or biological systems as well. And so it's really an intertwined web of, frankly, complexity and gnarly issues that we're dealing with when it comes to climate change in the ocean. And you can see this manifested. I won't get into detail in this impact or this figure, but you can, again, turn to the IPCC's report for a little bit more detail about just what those cascading effects as from one singular climate impact being sea level rise might look like, whether that is kind of local mean sea level rise or local extreme sea level rise, both of which we'll talk about a little bit later on, in a much more localized sense. And you can see again that there are not just obviously climate drivers to this, but non-climate drivers, again, things that we'll touch on a little bit later when we dig into kind of the importance of relative sea level rise here in the Gulf of Maine. But it's also good to know that the ocean is providing us with two enormous climate benefits. And one is just the extent to which it is serving as a heat sink for us. This plot shows basically the time series of excess heat energy in the Earth system as a result of anthropogenic warming. And you can see that the vast majority of that excess heat has gone into the ocean. This is, I think a lot of times people that aren't necessarily climate scientists see this figure and are kind of surprised to see that the, basically 1 degree of warming that we've seen so far is this tiny little, purple spot at the bottom here. But it just gives you an indication of just how significant the potential changes in the ocean environment are as a result of climate change. But it's not just the heat sink, it's also the carbon sink that is a big benefit to us from a climate perspective. The ocean absorbs roughly between 1/4 and 1/3 of anthropogenic carbon dioxide that we emit into the atmosphere. And as a result has protected us or buffered us against a lot of excess warming that would have otherwise occurred. Of course, that comes at the consequence of acidifying the ocean, but nonetheless, it has been an enormous climate service, so to speak. But I say to a point here because both of these things, can reach tipping points. And as we're starting to see in some ecosystems, we're already starting to approach some of those tipping points. And so the ability, for example, of the ocean to serve as that carbon sink obviously diminishes as the ocean warms from simple kind of high school chemistry. So let's focus in a little bit on some climate risks in the Gulf of Maine in particular. I highlight here just a number of things we'll talk about from physical, chemical, and biological interactions. We won't touch on all of these, but I'll dig into a number of them in a bit more detail. And it's certainly serving as a framework around which we at the Climate Center at GMRI are going to be focusing our work going forward. So a few years ago, Andy Pershing and others at GMRI were among the first to kind of really highlight that in the early 2000s, the Gulf of Maine was warming at a more rapid rate than anywhere else in the world, more or less. And you can see that highlighted here on the left when you look at the sea surface temperature trends for the decade of 2004 to 2013. And you can see just how much it stands out. And on the right, you basically see the histogram of those areas and just see what an outlier the Gulf of Maine was in terms of how fast it was warming. That doesn't necessarily mean it has warmed the most. That's important. It's the rate of warming. The Arctic has really warmed more in an absolute sense. And this rate, to some degree, has lessened in recent years, in part for a variety of natural variability reasons. But it's the bathymetry and the mixing that occurs in the Gulf of Maine, coupled with the northwestward shift of the Gulf Stream, have certainly impacted the warming signal that we're certainly seeing that is still an outlier in a global context. And you can see here a few of the first figures that I'll show of many from the Maine Climate Council Scientific and Technical Subcommittee's report on climate change in the Gulf of Maine. On the left, you see an observed time series extending back to 1900 through more or less present day. And then on the right, you see more of a projection of what that might look like for the decades to come throughout the rest of the century under two different scenarios, kind of a lower warming scenario in the blue and a higher warming scenario in the red. And you can see that these two different scenarios really start to diverge in mid-century when it comes to ocean surface temperature, with quite distinct consequences for coastal communities, the marine environment, and elsewhere. And I think it's important to keep in mind here, if you look that, when you look in at a smaller scale geographically, like the Gulf of Maine, you certainly see quite a bit of noise around any signal that you might be able to tease out. But what we're seeing, of course, is that what's likely to happen in the future is not going to be anything like the past. And so any sort of management or other decisions that we make probably should not be based on past performance. So if we think about a different type of metric for ocean heat, one option is looking at marine heat waves. And this is just sort of a schematic of how to identify a marine heat wave that basically looks at sort of the extended duration of heat over a particular defined threshold for I think it's usually about the 90th percentile above any sort of climatological mean for 5 or more days. So with that context, let's look at heat waves in the Gulf of Maine. And this is work that was started by Andy Pershing a few years ago, but has since been carried on by Adam Kemberling, basically looking at the prevalence, well, first of all, sea surface temperature anomalies in the Gulf of Maine since, what is this, I think 1981, I believe, is when the time series starts, above kind of the climatological mean. And you can see not only does is it warmer in more recent years, but you also see that these black lines indicate when we have been in a marine heat wave event. And you can see just the extent to which marine heat waves have been pervasive throughout the Gulf of Maine in more recent years. So if we turn to more of a chemical signal now, let's look at the ocean acidification. On the left, you have a figure of from the Climate Science Special Report, which was the first volume of the Fourth National Climate Assessment. The top panel shows a time series of atmospheric concentration of carbon dioxide increasing over time, obviously since the late 1970s, this figure shows. And on the bottom, you see kind of the consequence of that rising atmospheric CO2 manifested in the ocean with decreasing pH and a decrease in the concentration of carbonate. This is all coming from Hawaii, which is probably the longest continuous time series in the US. For those that are interested, I believe the actual time series is called the Hawaii Ocean Time Series Data. The acronym is HOT DOGS. That's all I know, which I think is kind of awesome. On the right, if we zoom in towards the Gulf of Maine, you can see some work from Joe Salisbury at UNH, who's certainly one of the leading experts regionally when it comes to ocean acidification. And his work has really shown that not only through the continuous monitoring at a buoy that they're maintaining, but also through some of the cruises that they've been conducting regularly, that extreme warming events throughout the Gulf have decreased CO2 solubility, increased salinity, and had consequences for both the saturation index of aragonite, which is a critical metric for shellfish formation, with consequences for acidification. And there are some complexities here I won't get into in this talk, but it's worth noting that there is a bit more variability depending on the metric you're using and depending on the scales that you're looking at. So when we look at kind of projected OA going out, you can see on the left here again another figure from the Climate Science Special Report that basically shows projected ocean acidification at the end of the century under a high warming scenario with significant increases in acidification in high latitude regions, and in particular in the Arctic. And you can see on the right, just a little plug for a paper that's coming out, or I think it may have just come out in Elementa by Sam Sedlecki and others at UConn, resulting from some of the work that was discussed and presented at the Gulf of Maine 2050 conference about 2 years ago now, that starts to look at projections of ocean acidification in the Gulf of Maine itself. So we've talked some chemical changes, talked some high level kind of temperature changes. We'll now pivot to a bit of sea level rise work, and a huge shout out to Pete Slavinsky here, who I think might be on the line. A lot of these next couple slides come from work that he's done at the Maine Geological Survey that are integrated into the Maine Climate Council's STS report. And you can see here just observed trends for 3 different places along the Maine coast: Portland, Bar Harbor, and Eastport. And you can see the long-term trend from the early 20th century through more or less the present day. And you can see in pretty much every case a fairly substantial increase in the rate of sea level rise in more recent years. And that's sort of indicated by the metrics that are shown. And that's a result of a variety of factors that we'll get into in a bit. So relative sea level rise is a really important aspect when we're thinking about sea level rise, because not only is global mean sea level at play here, which is really driven by not only the thermal expansion of water, but also the melting of the polar ice caps and glaciers on land. But there are other aspects that come into play as well, including glacial isostatic rebound as a result of plate tectonics and other things at play once the ice melts off of land, and also other aspects of kind of subsidence and uplift. A primary example is looking at what's happening in the Gulf of Mexico and in the Mississippi Delta region. A lot of the extractive behaviors that are going on down there have exacerbated the sea level rise issue, because you're basically taking, water out of a sponge and allowing that sponge to, collapse more. And so what you see on the bottom right here is a figure of projected sea level rise, projected relative sea level rise, I should say, by the end of the century under an intermediate scenario. And the colors indicate kind of the deviation from the global mean sea level. And so a global mean sea level rise of 1 meter by the end of the century, you can see that that is going to be significantly different whether you're in the Gulf of Alaska or the Gulf of Mexico. And you can see, for example, that the Gulf of Maine, you're probably going to see about a foot or so more sea level rise locally than you would in a from the global mean sea level rise. This is all work that Billy Sweet and company led out of NOAA a few years ago and continue to refine. So we look at relative sea level rise projections coming back more locally to the MCC's report, and some of the work that Pete has done. You can see that the MCC largely decided to focus on 2 different scenarios. There's the intermediate scenario and the high scenario. And this is kind of where sort of values and judgment comes into play, because you have to make some sort of a risk assessment, risk calculation as to what's going to be not necessarily even a likely outcome, but one you ought to be thinking about in terms of what you care about. And so these have been characterized as either a scenario against which we're committed to managing against, or a scenario against which we should prepare to manage against. And you can see what that looks like across the state, but generally speaking, by the end of the century, you're looking at an additional 4 feet of sea level rise that the state has committed to manage against. So what does that mean for coastal flooding? You can see here frequency of inundation in Portland, basically the number of hours per year that we've breached some particular threshold, and you can see what that has looked like. The black line is kind of the average over this entire time series, this basically 100-year time series, and the red line is kind of the more recent average over the past 20 years or so, and you can see a significant increase in that. But what's really kind of unsettling is that if you look at what happens if you add just a single foot of sea level rise against that coastal inundation for Portland, just look how much that's dwarfed. Look at the difference in the y-axis here. Whereas here, the range was 0 to 30 hours. Now you're looking at 0 to over 200 hours per year. So there are extraordinary consequences that can manifest just by a single foot of sea level rise. And as we showed in the previous slide, we can expect several more feet of that, which really necessitates the case for some strong adaptation planning. But it's not just coastal flooding, of course. There are going to be areas that have just been completely submerged. This is particularly true, again, for southern Maine in particular, where you're going to see not just dune area, but also sandy beach area loss. You can see in this graphic in the top right here, Wells Beach, which the light blue shows where there is developed land, and the dark blue is undeveloped land that will be submerged with 3.9 feet of sea level rise, which you may recall is the end of century commit to manage scenario that the state has planned for. Again, this work I believe was done by Pete and is included in the appendices of the MCC STS report. And what you can see is that basically you're looking at the y-axis on both of these plots is showing the number, the land area that is lost against a particular amount of sea level rise. And so you can see that with, roughly 1.5 feet or so of sea level rise, you're losing more than half of your undeveloped dune area, and the vast majority of your developed dune area is just one way to look at this. And then by the time you get to that 3.9 feet, you've lost most of your both developed and undeveloped dune, and you've lost about 70% or so of your beach area. So let's look at a different climate metric of heavy precipitation events. While there may not be a large trend in overall precipitation, what we are seeing throughout the Northeast is that the precipitation that is falling tends to be falling in much heavier events. And you can see that by the increase in size of these green, yellow, and red bars of this kind of frequency plot over time of different types of precipitation buckets, because they indicate the larger sized events. And another way to look at this is through work that NOAA has done through their state climate summaries, which are really well done. They have them for each of the 50 states. That really looks at kind of the change in the magnitude of 24-hour, 100-year precipitation event by county. And that's just one of many different types of kind of heavy precipitation metric one a climatologist can use. And you can see sort of a significant increase over time. And I should caution that some of these types of metrics can be awfully driven by endpoints. And so it's important to kind of look at a holistic range of different types of statistics to understand what kind of trend in heavy precipitation you may see. But across a range of metrics, we're seeing significant changes in the Northeast in heavy precipitation. And part of the reason why this matters is because extreme precipitation can lead to harmful algal blooms because of what that means for nutrient runoff, triggering HAB formation that can lead to fish kills. And here we see that in a couple of freshwater bodies in the MCC report. But Nick Record and folks at Bigelow are starting to look at, what this can look like, what this may look like in marine and coastal environments in the years to come. Let's see. Paloma, I'll come to your question at the end here, but in general, the answer is yes. A part of that is because of oil drilling, yes. So continuing the theme of kind of biological changes, we're also seeing changes in the phenology of species as well. Michelle Staudinger, a former colleague of mine at USGS a few years ago, led a very large review of phenological changes in coastal and marine species. And you can see again, just how significant and how pervasive some of these changes are, whether it is in terms of peak harvest, or when spawning occurs, when blooms occur, when migration runs occur. All these things have been evolving as a result of climate change, with consequences not just on the ecosystems that they operate within, but also on, frankly, the economies and communities that rely on these things for their livelihoods. And of course, that extends to fish productivity as well. The two iconic species around here, of course, historically, cod and lobster, decreases in their productivity have been linked to increases in temperature as well. And we can see this manifesting itself in species distributions as well. These are observed changes for 6 different types of marine species since 1970. And where kind of the center of latitude of their kind of abundance is. And you can see, generally speaking, a northward migration to higher latitudes, to more temperate waters. The terrestrial equivalent to this is some of the mountainous species kind of going up altitude. And so you see this across the biosphere. Frankly, species that where the climate velocity is faster than the velocity at which they can adapt biophysically, and so they're physically moving as a result. And if you look at the projected change, this is work that Kathy Mills and Andrew Allen at GMRI have been doing. You can see a change in the relative amount of biomass here for a variety of species, both in the Gulf of Maine and in southern New England, or the mid-Atlantic bight. And you can see declines in some species, increases in other species, and this is just by mid-century. And of course, it's worth noting that these are relative metrics, and so if there's a very low baseline to begin with, those percentages could look substantially large in relative terms. So what this indicates is that there's likely to be a need to sort of evolve the way we think about not just managing but harvesting our fisheries going forward, which speaks to kind of the max catch potential. And so this is a figure from the National Climate Assessment that shows projected change in fisheries by mid-century under a higher warming scenario. And you can see, generally speaking, some of the far north latitudes seeing some potential increases, whereas the vast majority of continental US seeing projected declines in the max catch potential from a holistic standpoint, with more exacerbated consequences in lower latitude places. So with all that, doom and gloom, it's really worthwhile to note that we do have kind of the knowledge and power to act in response to a lot of these risks and impacts. And so we're going to pivot now to what this might look like. This is kind of a complement to that figure I showed in the beginning from the IPCC special report a few years ago that looks at a bunch of climate response options related to the oceans. And the numbers here just correspond to the different chapters in the report, so don't really focus on that, but it's really just looking at different types of response options that we can take as a society, many of which, of course, are addressing the causes of climate change in terms of mitigation, but there's also a whole bunch of adaptation measures that we can take as well. And we'll largely be focusing on adaptation measures through the rest of this talk. So when it comes to sea level rise, there are, you could argue, 6 different ways you could respond. One of which is to do nothing and to kind of sacrifice the land or the development. Others include kind of advancing, which I haven't seen a whole lot of, protection, which is kind of your traditional seawall, retreat, which introduces all sorts of issues of equity and inclusive decision making, and as well as accommodation, which you're seeing more and more around here, as well as ecosystem-based adaptation in terms of restoring living shorelines and putting in other types of systems that can not only attenuate waves, but also serve as carbon sequestration reservoirs as well. But again, one thing I do want to emphasize here, of course, is that with all of these types of decisions, it's really important that you have inclusive and transparent engagement, because obviously when you're dealing with coastal communities, they vary from place to place, and it's very easy to make decisions that are inequitable or maladaptive. And so making sure that you have sort of holistic and comprehensive engagement is really important. And this is kind of one of my favorite figures or images, for better or worse, looking at what sea level rise can look like. This is from Scituate, Massachusetts. And this kind of demonstrates 3 of those 6 response options that I was just talking about. In the background, you see kind of no response option. In the midground, you see accommodation. These homes have been elevated on pillars, and in the foreground, you see quote unquote protection, which obviously has not protected enough, right? And so this is kind of always the challenge when you're dealing with development right on a shoreline like this. So one of the other things we talked about was the restoration of living shorelines. You know, we have a lot of rocky coastline in the northern part of Gulf of Maine, but also obviously, certainly as we go further south, quite a bit of marshland and sandy areas. And so there's a real opportunity for what I term kind of the triple win scenario, where you kind of maximize adaptation through kind of that wave attenuation aspect and coastal buffering, as well as mitigation by providing that carbon sequestration and biodiversity, you know, the extent to which you're restoring eelgrass or other habitats that can allow for spawning or juvenile species to kind of thrive. It really is kind of a helpful thing to do. Of course, all of this requires some kind of adept navigation of local and regional zoning, permitting, and regulatory frameworks that may not be straightforward. And so as communities sort of revisit their comprehensive planning processes, it'll be important to think about what that means for kind of land use planning and so on, which obviously has been a feature of the Maine Climate Council's recommendations, and Maine won't wait. Another thing that Maine has really been leading on is thinking about how we might buffer ocean acidification locally. Obviously, doing this at scale is a very different issue, and probably something you're not going to be able to do through these techniques. But we have been able to kind of demonstrate a few different techniques. On the left, you've got kelp cultivation that is being demonstrated by Bangs Island Mussels, and I know some folks at the Island Institute and elsewhere are engaged in some of this work with Nicole Price up at Bigelow as well. And on the right, this story was just featured in the Press Herald a week or 2 ago. This is literally in kind of my backyard in kind of Mill Cove, where they're testing out kind of recycled oyster shells and what that might be able to do to kind of raise the pH or lower the acidification in a couple of these places. And of course, you know, coastal acidification is driven by not just sort of the broader carbon uptake of the ocean, but also some of the things that are happening on land as well. So it's important to get a handle on those drivers of coastal environmental change as well. And so if we extend that a little bit to think about aquaculture, this is a story just from kind of Moog Sea Farm. You know, they've really been at the leading edge in thinking about how to deal with climate change impacting their operations in many ways. And they've, you know, because they have to shut down their farms if there's a heavy rainfall event because of what that might mean for runoff into their operations. And so a couple of things that they've been doing have been storing water ahead of those rainfall events so they can flush things out, raising the pH of water used in larval culture, constructing these complementary land-based facilities that you know, allow them to sort of diversify their risk and to really try to minimize the impacts that climate change and other sort of environmental disruptions may have on their operations. A couple other things that have helped out from a more kind of basic sense in some ways is really this improvement in monitoring and data presentation. The Friends of Cascade recently announced that they were successful in achieving their $1.5 million campaign to deploy more observational systems throughout Cascade. So here you see Mike Doan deploying some of those. And so we're getting kind of improved spatial and temporal coverage, which in theory should yield improved model performance, so we can have better knowledge of not only the baseline conditions, but also how that might change under a changing climate. And Niraku's recently released its new Mariners dashboard, which is kind of an updated version of our updated presentation of all the kind of near real-time, if not real-time, meteorological and oceanographic information that they collect through their array of buoys throughout the Gulf of Maine. That allows, whether it's kind of the recreational boater, the commercial fisherman, or even the surfer to go check conditions before they hit the water. And GMRI itself has our own kind of climate dashboard that has been of use as well to stakeholders needing this kind of information. And a lot of this can feed into so-called operational forecasting. And I won't spend a ton of time on this slide, but I think it's just important to know that there are a range of timescales and a range of geographic scales over which this is necessary. And having come from conversations in this space in the federal government, where there's a real kind of divide between the weather enterprise and the climate enterprise, there's a strong desire to sort of bridge that seasonal to decadal timescale, which is really difficult to capture in a modeling framework because it doesn't neatly fit. And so there has been some work, frankly, across administrations of trying to address that gap, which of course is driven largely by oceanic conditions and therefore the need to really integrate that to provide more local specific information, which goes to kind of the next step further of thinking about, okay, well, you're looking at sort of the physical changes in the Earth system. We should probably understand the biological changes as well and what that might mean for fishery management. And so Lisa Kerr at GMRI is leading a project, the Northeast Climate Integrated Modeling Framework, or NCLIM, trying to really get at this question of what are the conditions under which future fishing will occur. And the idea here is to really look across different types of models and different types of conditions to really inform fishery management decisions in the years ahead. So we can sort of, again, account for the non-stationarity in which we're operating, that is not just biologically occurring, but also certainly physically and chemically as well. And again, access to species is kind of a response option that we need to be thinking about, right? And so if you recall, just one example, I mentioned sort of from a previous slide, you can see the northward migration, so to speak, of black sea bass and the projected increase in relative biomass in the Gulf of Maine, fairly extraordinary in the years to come. But if you look at, where the licenses exist to access black sea bass, you see that there's virtually none in Maine and New Hampshire. And so this really opens up the need for kind of a dynamic permitting system of sorts that we're keenly interested in engaging on and figuring out how to really evolve the permitting system to account for this type of dynamic nature of the regional fisheries. And this extends then to the fishing communities themselves, right? And so the idea is that, these communities, the fisheries are evolving, the communities therefore are going to have to evolve with them or risk real severe economic decline. And so one of the things we're trying to do is to really look at a suite of different adaptation options for these fishing communities and engaging with people in those communities, whether they're, whether they own infrastructure on a working waterfront or are harvesters themselves, and really sort of engaging with them in not only the findings that we're discovering, but also to sort of think about some of the questions and issues that they're grappling with that may either serve as barriers or enabling conditions to allow some of those adaptation strategies to move forward. And so that's some ongoing work that Kathy Mills is leading. And finally, on the response options front, I'll just highlight marine geoengineering techniques. The figure on the left here comes from a UN working group report a couple of years ago that shows a variety of different things that have been mentioned for the that we could do in, under, and above the ocean, whether it's anything from marine cloud brightening or wide scale kelp cultivation or artificial upwelling. There's a whole slew of potential opportunities that come with a wide range of governance, ecological, and potential societal acceptance issues that have yet to be grappled with. And it's worth, in this sense, if you're interested in and aren't aware, the National Academies has been doing some work in this historically, and Scott Doney is leading a report right now that is looking to lay out a research agenda for a variety of ocean CDR techniques that I highlight here on the right. So if we zoom in a little bit more, this is the kind of final section of the talk, and then we'll open it up for some questions, but just want to kind of highlight what we're thinking about at the Climate Center at GMRI. For those that aren't familiar with our organization, we're a roughly 80-person nonprofit on the waterfront in Portland that really emphasizes three big areas of work. One is our fundamental research into kind of fishery science and management. Our second is in education. We basically welcome, I think, something on the order of 10,000 middle school students from across the state of Maine into our interactive Cohen Center Learning Lab every year to understand what's happening in the Gulf of Maine, how it's changing, and why it matters to them. And then we also have an extensive community team that really engages throughout the supply chain of the seafood economy here, and ensures that we're able to sort of do research that is not only user informed, but also user relevant. And that's certainly informing the way we approach our work within the context of the Climate Center. And so that's really kind of taken us to this, which is kind of the framework for the Climate Center itself. It all starts with kind of a clear articulation of the problem that we see, and that's namely that climate change represents an existential threat to coastal communities as we know them now. But it's important to note that it doesn't have to be, right? As we see it, coastal communities can thrive in a warmer world if they are able to leverage climate action from the local to the global scale, and that means both adaptation and mitigation. And the way we're going to accomplish that is by building on our current capacities in these four core areas of fishery science and management, seafood business innovation, aquaculture development, and coastal resilience. And over the past several months, been doing a lot of outreach to partner organizations to understand the work that they're doing a bit more and to really understand some of the needs of our stakeholders to see where we can add value to the landscape of really great work already going on out there. And in that sense, there were three kind of areas that I thought could really use some additional capacity, and that's in the realm of climate policy and climate mitigation, thinking again, both sort of traditional mitigation, but also in some of these negative emissions approaches, as well as in the realm of climate finance, making sure that communities don't just stop at coming up with a climate action plan, but are also matched with the resources that can actually turn that into on the ground action. But also thinking about other aspects of climate finance, whether it's kind of shared liability regimes between offshore wind developers and fishermen, or diversified risk strategies for small scale aquaculturists or things of that nature. And it's important to point out that all of this is only possible through kind of sustained engagement with our stakeholders, whether it is the vessel level fishermen or our elected leaders. And so that sort of engagement is really what provides us with kind of the knowledge to provide those kind of customized solutions. And so if we think about what our process is going to look like in the Climate Center, we are an end-to-end provider of climate services. And so we not only create a lot of this technical fundamental knowledge in-house through our research team, but we're able to translate that into on-the-ground action. And all of that, again, is through that stakeholder-informed solution development, where we are really trying to get at sort of where those leverage points are in a decision-making process so we can kind of affect change. And you can think about this in kind of this sort of kind of chain of knowledge, so to speak, where we start with sort of that upstream development of technical expertise, whether it's high resolution sea level rise modeling or an understanding of a seafood business's carbon footprint and the opportunities to decarbonize. And then handing that technical information off to either our municipal engagement specialist or a corporate engagement, and getting that knowledge into the hands of those decision makers, so we could do some kind of knowledge translation and bring back in-house some of the more nuanced issues that they're grappling with, so we can develop, kind of co-develop some adaptation and mitigation options, and finally match that with kind of the financing and other things that we can really turn this into solutions. And so briefly just pivot to talk about our municipal climate action program, where historically this has been really about kind of sea level rise awareness raising in communities, in part, not just through community programming, but in the development of high school curricula and sustained kind of community engagement in citizen science acquisition of sort of where flooding is occurring. That has resulted in some community mapping projects and ultimately in greater technical awareness within and through communities that is then kind of brought forward a little bit into, and we've had real success in that space in communities like South Portland. And we're now just working with a variety of partner organizations to expand this work into a number of rural communities throughout coastal Maine, to not only train them in resilience to sea level rise, but also to kind of build awareness of what some of their vulnerabilities are, what critical infrastructure is at risk, and to really think about how they may adapt to the changes that are to come. And as we move forward, we're going to build out that kind of historical focus on sea level rise awareness raising and capacity building in municipalities to a more holistic municipal climate action program. And the plot on the left here just shows basically a map of Maine, where with color coding showing the different the range of planning capacity in communities throughout the state. And you can see that there's a substantial number of communities that have really no in-house planning staff or really no resilience planning capabilities throughout the coast. And so we want to be able to get into those communities and really help them not only build climate literacy, but to convene stakeholders to develop equitable solutions and really, again, kind of partner to find the financing to make their communities resilient and thrive in that warmer world. And so we've got a budding partnership with the Greater Portland Council of Governments, the regional planning organization for our region here. We're looking to extend that to other municipalities as well. And just recently have heard that the town of Falmouth Town Council has approved some work in this space. So again, looking to leverage the state's climate action plan along with more local climate action plans, like the One Climate Future joint climate action plan for the cities of Portland and South Portland. Obviously, other towns throughout the state don't have the capacity or resources that may allow for something as comprehensive or holistic as One Climate Future. But the important thing is to note is that that template now exists, and therefore the barrier, the activation energy to complete something like that will be much lower. And that's definitely a place where we're hoping to play a role. And just the counterpart to that municipal climate action program is the corporate climate action program. And so we're thinking of really trying to leverage the momentum that a number of forward-leaning companies in the region have to take action in the climate space, to really advance not just mitigation action, but also resilience through their operations and their supply chains. And so we see this as being sort of twofold. One being kind of a focus on the seafood supply chain, where we historically as an organization have had really strong trusted relationships, and also geographically thinking about, GMRI being, kind of the climate player in the greater Portland area, really leveraging that momentum to help waterfront businesses and others really kind of lean in on that work. And so we've been in conversations with DMR, who's been charged with standing up a seafood business council under the auspices of the Maine Climate Council about what that might look like and how our engagement and leadership with organizations like Maine and the Island Institute might look going forward. So with that, I just want to kind of end on this slide of what we're really hoping to achieve through the work of the Climate Center, and that really is these thriving coastal communities that can sustain these fisheries that we've had for generations, that we can build resilience in our climate infrastructure, and that ultimately, we have economies that can thrive in a warmer world with equitable and just communities that allow, again, for us to kind of capture the economic opportunity that does come from responding to climate change. So with that, maybe I'll pause. I see we've got a few minutes, hopefully, for questions, and just thank everyone for their attention.
Thank you, Dave. That was a very robust and informative presentation, a great review. We'll open it up to a few minutes of questions here. I see one, Brenda, quite a few. If you would go ahead, please.
Sorry, that was not a question. That was just a
An applause. Okay, sorry.
I really enjoyed the presentation, however.
Thanks, Brenda. Yeah, and I'll just come back to I think it's Paloma, her question in the chat window when I did speak about sea level rise in the Gulf of Mexico, and the fact that extractive actions can exacerbate relative sea level rise. Yes, hydrocarbon extraction. It's not just oil drilling, it's natural gas drilling, but it's also freshwater extraction as well, by draining aquifers and things like that. That can certainly exacerbate those issues.
Okay, so it's the extraction on land that's causing the subsidence, not the extraction in the Gulf of Maine itself in the ocean.
I have to plead a degree of ignorance on that.
Okay.
I would, yeah, I'd have to dig in a bit more. I don't know if Pete's still on the phone. He might know the answer to that.
Hey everyone. Yeah, I would say it's a combination of the two, land and water-based extraction, including hydrocarbon and groundwater extraction. And Steve Dixon, my coworker at MGS, also put sediment compaction in the delta is pretty important as well. Thanks.
Thanks, Pete. Thanks, Steve.
Questions from others? I have, if nobody else does, I have a quick question. It's a little bit outside of what you spoke about, but it is something that you provided us with a very informative PowerPoint for looking at the catch projections for the future. Obviously, Maine losing, Maritimes getting closer to even, and Greenland being the big new place for catch fisheries, which of course is expected from a cold ocean. Southern Ocean is our biggest food source. So you've spent a lot of time in federal government and internationally. Are there any discussions, I'm sure there are, about beginning to not just share, but ways in which the fishing communities in places like Maine and the Maritimes can begin to interact with Greenland fisheries in order to benefit both, obviously, because that's where the food will be coming from?
Yeah, it's a great question, great observation, and you know, I can say this, that the international negotiations that I was a part of, you know, the UN negotiations that were the climate negotiations, frankly, didn't get into fisheries issues explicitly. You know, there's UNCLOS, the law of the sea, and a variety of other sort of international fora where those fishing issues are handled. I didn't directly engage in those, but I suspect they're definitely going to come into play. And another body to keep an eye on in that sense, of course, then is the Arctic Council, which I know has been quite active in this space, and in particular, ensuring that the rights of indigenous and local communities are respected as more and more pressure is put on these Arctic communities.
Our institute, largely because of Jasmine Saros, has a very large program, I think I mentioned, in the Arctic, and that's something, a serious thing for us to think about. Other questions? Kat, please go ahead.
Hi, thanks for a really, really interesting talk. I was wondering, you briefly mentioned that there are new sensors that are being deployed in the Cascade Bay area. Are those mostly temperature-based, or are they also looking at carbonate system parameters? And what else are they measuring?
I believe it's where you can go on Friends of Cascade Bay website. They've got some. I think they do some pretty much near real-time presentation of their data. I don't think it's. You know, I think it's probably some PCO2 and things like that, but I don't know the extent to which they're like, yeah. I mean, I think they're fairly basic instrument packages that can largely be deployed and forgotten, not heavy maintenance ones. But I would encourage you to, and I can dig up the website here in a second or follow up with you afterwards. But Mike
Thanks.
Doan is a great resource for that, for sure.
I do know the website. I was just wondering if the new deployments had new sensors on them or not.
Right.
Thanks very much.
Yeah, for sure.
Other questions? I don't see anything. I would like to ask one more question in the minute we have remaining. Wind power, obviously very big issue for the future of Maine. On the other hand, there are a lot of people in the fishing industry who are very concerned about this, and University of Maine is tied up in this. What do you think should be done by GMRI, the state, in order to resolve this?
Mm-hmm. I think, you know, one thing I think we're seeing play out in real time here is just how important process is, right? And you know, I think there's obviously there's increasing urgency to decarbonizing our electrical system, and in the process electrifying things that are not already electrified. You know, and I think the role of, you know, for GMRI, we've always kind of positioned ourselves in a bit of a convening role, and I think one of the important things we're going to need to sort of reconcile here is really how can you know, you can realize kind of a balanced use of the ocean space and sort of respecting sort of historical precedent and the generations of activity that have informed sort of a cultural heritage around different activities, while sort of embracing the economic opportunity that can come from the response to climate change. So I think, again, process matters here, and I think really sort of listening and trying to identify, co-develop those solutions. And I think the problem sometimes is that in the rush to act quickly to address what is, by all accounts, a very urgent problem, we just don't want to sacrifice kind of a user-informed process as a result. And I think there's a variety of solutions, whether it's some sort of community compensation structure or some of that shared liability I talked about, or otherwise. I think there are lessons to be learned from overseas. Paul, you mentioned kind of the basically the North Sea. The only other floating wind array in the world is off of Scotland. They have worked out an arrangement with the fishermen there. Whether or not something like that is transferable to here, I think remains to be seen. But if nothing else, it can be instructive to the policy discourse that we're trying to have here.
Thank you. I think one of the other things that might be very valuable would be to be much more transparent about where and how large an area the wind field will actually be contained within. And obviously, some of it's being leaked, but most of the discussion has really had to do with where the initial installations, test installations will be versus where the ultimate system will be. It's a very important thing for the state, but obviously the marine industry is very important too. And just as Biden is making the case that climate change will develop more jobs, that case should be probably made here. And I'm sure GMRI will be an important part of that story.
Yeah, and I think one other thing I'll just say here is I think there's a really interesting sort of cross-jurisdictional policy problem to be sort of figured out, because these things are going to be in federal waters. They're going to need to traverse state waters, and then they're going to come on shore at the local township level. So figuring out, all the players that have an interest in those decisions is going to be super important.
Well, we're out of time. We greatly appreciate your taking the time to speak to us and for a very informative presentation. And we look forward to doing a lot more work with GMRI in the future. Thank you so much.
Wonderful. Thanks, everyone. Appreciate it.
Thank you. Dan, did you want to close the session?
Just to say, this is the last Borns for this year. As I said, we'll be resuming in the fall. Based on the results of a survey of grassroots just mentioned, the reason we're going to the same format in the fall is that we have the 50th anniversary celebration in the spring, which is in the time we would normally use for the Borns, and having two large face-to-face meetings at the same time would be very difficult. But we'll reassess based on how next year goes after that year. Have a great summer, everybody.